Hello everyone, this is Pooky Codes, and today I'm going to explain what the hell a neural network is from the bottom up, assuming no prior knowledge at all. So let's get started. So, we're first going to start by explaining some examples and seeing how we can discover how neural networks could be created. So let's say I want to create something that can predict if I can drink alcohol. So as an input, I would give the age, which is, I will name it x1, and it will have an output, which is, can I drink alcohol, which is y1. So it's going to be a 0 if I cannot drink alcohol, and a 1 if I can drink alcohol. So if I am over 18, I can drink alcohol. So we're just first going to start by a simple model, just equality. So y1 equal x1. So when we test it, we have x1 equals 17, which gives us y1 equals 17, but we want the 0. And we also have x1 equal 20, but we have y1 also equal to 20, which gives us not 1. So the solution is to create a function that I will call step, such that when it is below 18, it will output 0, and when it is above 18, it will output 1. So our updated model would be y1 is equal to step of x1. So if I test it right now, what is step of 13? 13 is smaller than 18, so it's 0. So it's right because a 13 years old cannot drink alcohol. When I put 20, I have 20, which is bigger than 18. So step of 20 gives 1. And that means that a 20 years old can drink alcohol, which is correct. So we'll now move on to a bit more advanced example, which is, can I eat in the kids menu? So as an input, I'll give the age, and as an output, I'll have to know, can I eat in the kids menu? So it's going to be 0 if I cannot eat, and 1 if I can eat. And if I am under 12, let's say I can eat in the kids menu. So we'll do the same thing as we did last time. So we'll have a new function called step 2 of x, such that if x is smaller than 12, it is 1. And if x is bigger or equal to 12, then it is 0. So our updated function is y1 is equal to step 2 of x1. So if I put 11, for example, 11 is smaller than 12, which gives us 1. So this means that 11 years old can eat in the kids menu. If I put 25, for example, I have step 2 of 25. 25 is bigger or equal than 12, so this gives a 0. So this is right because a 25 years old cannot eat in the kids menu, sadly. So it is a problem because it keeps getting quite repetitive, because we always have to create a new function named step that has 0 given a certain range and 1 for another range. So the solution, it is to create z step function. So the step function would be that it's going to be 0 for x smaller or equal than 0 and 1 for x bigger than 0. So now it's time to adopt our two previous examples. So if you want that when x is bigger than 18, y is equal to 1, and that when x is smaller than 18, y equals 0, we can shift step of x by 18 to the right. So we have y1 is equal to the new step, x1 minus 18. This gives us, for example, when I have x1 equal 19, I have y1 equals step of 19 minus 18, so which is step of 1. And this is bigger than 0, so as output, I'll get 1. If I have x1 equals 13, I'll see that there is y1 equal to step of 13 minus 18, which is then step of minus 5, and this gives us 0. So for the second example, if you want that when x smaller than 12, y is equal to 1, and that when x bigger equal to 12, y equals to 0, we can flip the function and then shift it by 12 to the right. So how does that work? We can just say y1 is equal to step of minus to flip it times x1 minus 12. If you expand that expression, you'll get step of minus x1 plus 12. So let's test it with, for example, 11. So step of minus 11 plus 12 gives us 1, which means that 11 years old can eat in the kids menu. When I put 18, for example, I'll have step of minus 18 plus 12, which gives minus 6. And since this is smaller than 0, it means that I cannot eat in the kids menu if I'm 18 years old. So we cannot generalize this form as y1 is equal to step of some form of constant w1 times x1 plus another sort of constant called b1. So in the first example, it was y1 is equal to step of x1 minus 18, and this gives us as parameter w1 is equal to 1 and b1 is equal to minus 18. In the second example, we had y1 is equal to step of minus 1 times x1 plus 12, which gives us as parameter w1 equal 1 and b1 equal to 12. So now I'm going to introduce you to the terminology. So y1 is called the output, x1 is called the input, and step can actually change depending on neural networks, and this is called the activation function. W1 is called a weight, and B1 is called the bias. So next up, we are going to look at multiple inputs. So if you like this content, subscribe, hit that bell icon, like, and do all that good stuff, and see you next time.